Announcing the arrival of Yang Berbahagia Profesor Datuk Teknologis Dr. Wahid bin Razak, Vice Chancellor of University Tun Hussein on Malaysia. Lagu Bangsa Johor dan Negaraku. The ceremony will begin with a citation of doa. I would like to invite Saudara Muhammad Halimi Zulhi bin Bakri to lead us in the citation of doa.
Al-Fatiha. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin wal aqibatu lil muttaqin wassalatu wassalamu ala sayyidina Muhammadin wa ala alihi wa ashabihi ajma'in. Allahumma antal azizul jalil. Sesungguhnya kami pada hari ini ingin merafakkan kesyukuran dan kepujian terhadap-Mu atas kurniaan-Mu yang tidak ternilai dan nikmat-Mu yang tidak terhingga kepada kami. Allahumma ya Hakim ya Azim. Sesungguhnya kami berhimpun di sini dalam majlis syarahan perdana Siri 3 bagi tahun 2019 bagi menyatakan kesungguhan, komitmen dan iltizam kami dengan roh dan semangat untuk membangun, membina serta mendidik dan memartabatkan anak bangsa supaya berbudi dan berjasa kepada agama, bangsa dan negara. Justeru, berkatilah pertemuan kami, berkatilah jua usaha kami, ilhamkanlah dalam fikiran dan minda kami idea-idea yang bernas, pandangan-pandangan yang jelas dan keputusan yang terbaik sehingga bermanfaat bagi dunia dan akhirat kami. Bukakanlah kepada kami pintu-pintu hikmah yang dapat meneroka lautan ilmu-Mu dalam mentauhidkan ya Allah. Sesungguhnya satukanlah hati-hati kami bersama kepimpinan yang ada. Eratkanlah silaturahim di kalangan kami dalam melunaskan janji-janji untuk membawa universiti dan negara ke arah kemajuan berlandaskan syariat Nabi Muhammad sallallahu alaihi wasallam. Padukanlah tenaga dan usaha kami untuk memartabatkan Universiti Tun Hussein On Malaysia di peringkat dunia dan antarabangsa. Allahumma ja'al jama'na hadha jama'an marhuma wa tafarruqana min ba'dihi tafarruqan ma'suma. ولا تجعل اللهم فينا ولا معنا ولا من يتبعنا شقيا ولا مطرودا ولا محروما. اللهم اجعل خير أعمارنا آخره وخير أعمالنا خواتمه وخير أيامنا يوم القاك فيك. اللهم اغفر لنا ذنوبنا ولإخواننا الذين سبقونا بالإيمان ولا تجعل في قلوبنا غلا للذين آمنوا ربنا إنك رؤوف رحيم. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. وصلى الله على سيدنا محمد وعلى آله وصحبه وسلم والحمد لله رب العالمين.
Thank you, Saudara Muhammad Halimi Zudi bin Bakri. Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Yang berbahagia Profesor Datuk Teknologis Dr. Wahid bin Razali, Vice Chancellor of University Tun Hussein On Malaysia. Our special guest, Yang berbahagia Profesor Dr. Haji Mahrazai bin Said, Vice Chancellor of College University Islam Melaka. Yang berbahagia Profesor Dr. Ismail bin Abdul Rahman, Deputy Vice Chancellor Academic and International. Yang berbahagia Datuk Dr. Abdul Razak bin Haji Umar, Provost of UTHM Pagoh Campus. Yang berbahagia Dr. Zulkifli bin Ta'an, Acting Deputy Vice Chancellor Student Affairs and Alumni. Yang berbahagia Profesor Dr. Khalid bin Hasnan from Faculty of Engineering Technology, Speaker for the 3rd UTHM Lecture Series Program 2019. All UTHM senior officers, lecturers and students. Alhamdulillah, all praises to Allah, as with His grace we are all able to gather here in the 3rd UTHM Lecture Series Program for this year. Ladies and gentlemen, this program is exclusively organized by the Chancellery Office and Faculty of Engineering Technology, UTHM. It is also aimed to provide a great opportunity for all to gather, learn and discuss the ideas and issues addressed in the lecture with the university community. Next, without further ado, I would like to invite Yang Berbahagia Profesor Dr. Ismail bin Abdul Rahman, Deputy Vice Chancellor Academic and International UTHM, to introduce our keynote speaker.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Distinguished guests yang berbahagia, Profesor Datuk T.S. Dr. Wahid bin Razali, UTHM Vice Chancellor. Yang berbahagia, Profesor Dr. Mahrazai bin Said, Naib Chancellor, College University Islam Melaka. Profesor, Senior Officer, Head of Office, ladies and gentlemen. All praises are to Allah Subhanahu wa Ta'ala and salam upon our beloved Prophet Muhammad sallallahu alaihi wasallam and his family, companions, faithfuls and honest followers till the ends of the time. First and foremost, I would like to express my gratitude for the opportunity of being here at the UTHM Premier Lecture Series 3 for 2019, an event filled with scientific pieces of information and intellectual tradition. This program is organized by the Chancellery Office and the Faculty of Engineering Technology, FTK. Ladies and gentlemen, today we feel honored to have Professor Dr. Khalid bin Hasnan, Professor of the Faculty of Engineering Technology, to share his field of expertise with us. At glance at his background, Professor Dr. Khalid was born in Kuala Kangsar on the 24th November 1960 as the 11th and the youngest child in his family. His father was then the headmaster at Sekolah Kebangsaan Jerlian, Kuala Kangsar, and his mother, housewife, managed a few acres of land at Kampung Bekor on the other side of Sungai Perak. Professor Khalid begins his primary education in Clifford National Primary School, Kuala Kangsar, in 1967. He then pursued his high school study at Sekolah Menengah Sains Kedah, Sungai Petani. Due to his achievement in 1977, MCE, National Certificate of Education Examination, he was awarded the scholarship by the Ministry of Education to study mechanical engineering in United Kingdom. He then obtained A-levels at Graham College for further education in England, and here was where the love blossomed for Professor Khalid when he met his classmate and later the only wife, Dr. Shuaida binti Tahir, currently the director of the Southeast Asian Minister of Education Organization, Regional Center for Education in Science and Mathematics in Penang. His education continued and was awarded Bachelor of Mechanical Engineering from the University of Birmingham in 1983. Then Diploma in Education from University Kebangsaan Malaysia Bangi in 1984. Then with a Master of Automotive Engineering from University of Southampton, UK in 1992. And last but not least, PhD in Manufacturing System Engineering from the Sheffield Hallam University in 2006. So his career teaching began on the 2nd May 1984 at the Jabatan Kejuruteraan Jentera Politeknik Engku Omar, Ipoh. He was appointed as the head for the automotive unit before pursuing his master's degree in automotive. Professor Khalid was then posted to Polytechnic Kota Baru, Kelantan for 2 years before being seconded to UTHM, Pusat Latihan Staff Polytechnic at Tarikh, Batu Pahat in January 1994. He is among the few pioneers lecturers still in the service and have been involved in the growth from the humble beginnings of PLSP to Quito to the greatness of UTHM we have now. With over 35 years of experience in higher education in the field of automotive, manufacturing, system and railway, Professor Khalid has been speaker in various conferences and seminars, both at national and international level. With almost 9 years of experience and engagement in developing academic programs as well as research activity in transportation engineering, his expertise in this area is undeniable. Ladies and gentlemen, without further ado, please join me in welcoming Professor Khalid to deliver his lecture entitled Friendship in Global Radio Technology and Industry. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin wassalatu wassalamu ala asrafil anbiya wal mursalin wa ala alihi washabihi ajmain. Yang berbahagia Profesor Datuk Wahid bin Razali, Naib Chancellor Universiti Tun Hussein Malaysia. Rakan saya, Profesor Dr. Said, Vice Chancellor KUIM Melaka, Timbalan Naib Chancellor Akademik, Profesor Dr. Ismail Abdul Rahman, Senior Management of UTHM, from the industry, seniors, the faculties. Assalamualaikum warahmatullahi wabarakatuh, and good morning. So Alhamdulillah, praise all to Allah subhanahu wa ta'ala. I've been given this opportunity to share with you some of my journey in this field of railway, particular, where in short, I'm very passionate about this from the very beginning. I was born in Kuala Kangsar, and I was raised in Kuala Kangsar. Clifford Primary School is just next to the railway station, very near to the railway station in Kuala Kangsar. And in fact, my classroom was very near to the rail itself. So that's where the passion began. Okay, right from the from primary school to secondary school and so forth. So when I went to UK, the situation was railway in Malaysia seemed to be in a decline, because it was so underdeveloped. So when we went to UK, we see the advancement of railway in UK. So Grantham College, by the way, where I did my A-levels, was very near to the railway. So in fact, we commute to Ayam and so forth using railway. So how convenient, how reliable it is. So to start off with some, okay, what you see there is cartoon strip of one train travelers. So you see, in a train there are travelers hoping to do many things. Okay, so what can you see there? All people from all walks of life, okay, in that one coach or one station. So here you have this KTMB, you have this LRT, you have many things. In the early days, we had only KTM. So, but then in the 1990s, where Malaysia began to expand the railway system, concurrent with the world actually, before 1990, the world was actually stagnant development. In the 1990s, the global world, progressed very fast, including Malaysia to a certain extent. All right. Okay. I purposely leave this blank. Okay. I want you to answer me, what would be your wish list? When you get on the train, what would be your wish list? Number one. Anyone? Anyone? Safety, yeah. Safe arrival to your destination. What else? Fast, speed. What else? Punctuality. What else? Cheaper, affordable. Yes. What else? What else? Okay, we go to the next slide then, please. Okay, basically, from the railway industry point of view, they would like to satisfy the customer needs. Okay, so basically it's on those three: how, when, and where. Because when you travel, it's the place from where we are, destination where you want to be. Okay, that about the place. What about time? Okay, time is very precious. Back in the early days, time was not so precious, but nowadays, time is getting more and more precious. Okay, you count by the seconds, no more hours. Back in the early days, in the 80s, in the 70s, if you watch P. Ramlee movie, 1 hour delay, biasa. Now no more. In trains, we call it headway. Headway is where then when one train arrives, and then it goes, and then the other train arrives. So the time between one that's leaving and the one that is coming, we call it headway. Now, the common standard now among the urban rail, headway is 90 seconds. 90 seconds. How many minutes is that? 1.5 minutes. Very fast. So that's why if you were to miss a train, you don't have to worry so much, because the next train will come in just another few minutes. Okay? Okay, you want to make it to be fast. Time. You want to have it affordable so that you can get the volume. As many people, as many as possible to ride on the train. We call it ridership. Okay? Dense. Not forgetting about comfort. We try to make, MRT, mass rapid transit. Okay? So hopefully in days to come, or in the years to come, it will carry about 1,000 per trip. Okay? Mass. But now it's not that many, because not many service and not many, in terms of demography, the stations are not that dense yet. And we have to sustain, because cost of developing a railway line, a railway system, is not cheap. No railway provider is making profit. Nowhere in the world. Nowhere in the world, except for 2 places. That will be in Japan, where it is just break even, no profit. So train service is actually a service to the people, not so much for profit making. Yeah, but the downstream activities, like the stations, where the stations are developed, we call it TOD, transit-oriented development. Okay, where those towns will progress and develop, and that's where the economic will grow. Okay, next, please. Okay, basically these are the topics that I'm going to discuss today. So I'm going to go very fast on certain areas, and I'll be using some videos to help us to understand better. Okay, so next, please. Okay, now, about mobility. Transportation is about mobility, whether it's passengers or goods. Okay? It's about mobility. Transportation is about moving from one place to another. If you are to have a person, okay, a human, you want it to be there, safe and sound, and at the time where it should be. We call it door-to-door service. Okay? Door-to-door. That means you get out from your house and you arrive at your office or whatever, the shop or whatever. It's called door-to-door service. Now, just to compare between, there was an argument about high-speed rail, whether we need it or not. Okay? I'm going to discuss it a bit more detail later on. But just to give you some insight about this door-to-door idea. Now, the flight, let's say, from JB to KL, 1 hour. Okay? It's very short. But from your door to arrive at the airport, that may take 1 hour. Okay? And to be there 1 hour before the flight, that's another 2 hours. And once you reach there, from that departure or the arrival hall to your place, maybe 1 hour. Okay? So now that may take about, say, 4 or 5 hours. But if you take a high-speed train, let's say, from JB to KL, in just less than 1.5 hours, maybe slightly more than 1 hour, because the target is from KL to Singapore in 1.5 hours. So you can imagine from KL to JB in maybe just about 1 hour. Okay? There's no hassle about, there will be less time for us to travel from the first door to the station on the train, and then you arrive, and then you go to your next door. Okay? So this is time saved. Okay? All right. Can you go back? All right. So about mobility, I just want to explain to you about the mobility 1.0 and also IR 1.0. Okay? So in terms of mobility, in the early days, it's basically on waterways, on horses, okay? And the industry then was focused on the agriculture. When you go to the next step, 19th century, IR 2.0, and alongside with it, mobility 2.0. So you see, steam-based technology, industrialization, metallurgy, and so on and so forth. So this is where rail comes in. And, okay, my first question. Salah, ada hadiah tidak? Ada ambil hadiah? Ada buat hadiah? Ada, tak ada? Oh, tahu, okay. What year was the first train in Malaysia, Tanah Melayu? What year was it? Anyone? Anyone? Okay, I give you a clue. KTM celebrated 125 years. Okay, KTM celebrated, I think I have some KTM friends with me. Yes, I know. Yes. 1885, but the clue was KTM celebrated 125 in the year 2010. Okay, now that is to show how old is our railway industry. It began 1885, okay, but in Japan, okay, anyone? What year? 1873, just 12 years difference. And look where Japan is now in terms of railway. Okay, so we have to catch up, and this is the theme for this lecture. For us to aware that we need to go fast, we need to be at par with the world global railway industry. Okay, next please. Now, the first thing is about digitalization. We call it digital railway. So, you know this IIoT. You know about IoT, right? But this is IIoT. Okay? Industrial Internet of Things. So this is why we call it, we have the digital twins, we call it, of critical assets. Okay, now, let me explain what asset is in terms of railway. Anyone? Say, what do they understand by asset? Okay, something that you have, okay, that is valuable, okay. Now, asset in railway terms include the station, the infrastructure, the rolling stock. What is rolling stock? Rolling stock is the train itself. The vehicle that moves, that is the rolling stock. When railway is just not about rolling stock. When we talk about asset, it includes stations, all the infrastructure, all the communication, all the signaling, anything that makes your ride comfortable, punctual, and so on and so forth. Anything that provides those kind of satisfaction is asset, and it is valuable. We have in Malaysia, we call this PAK, Perbadanan Aset Kereta Api. Okay, Perbadanan Aset Kereta Api, or we call it RAC, Railway Asset Corporation. So they handle all the assets of railway previously by KTM. KTM, by the way, is rich, but in terms of operation, they are not making money at all, always losing. Okay, so now, when you say digital twins of critical assets, digitization allow the twinning, as that is an asset, But digitally, you can monitor, you can control, you can do anything with that data. Now, let me go again, the replicate on the real-time performance of live asset. Live asset. So that means from, it is real-time, no delay. Whatever happens, you know. Okay? So in Sweden, for example, they have this, the students' commuter section, they call this commuter prognosis. What is prognosis? Okay? In terms of prognosis, they are able to predict in advance what's going to happen if you don't take any action. So this is the good thing about digitization. It allows you to simulate what will happen in certain time, at certain time. So in this case, the traffic control and so on and so forth, including the condition of the rolling stock of the structure. So we have this AR and VR, augmented reality and virtual reality. So this enhances the learning and discussion session so that the learning is no more dirty. Okay? Like we have now here in front of us, 20 of them. So we let them learn about the railway system without their hands dirty yet. But next week, they will dirty their hands, not so much like, maybe in our grandfather's time, but yeah, hands-on. Anyway, so augmented reality and virtual reality help the potential workers to understand the system very deep, very, very deep. So we have these smart trains and connected railways. Smart trains meaning they can do by themselves. Okay? I'll show you some video in a bit about this. Okay? So we have this advanced analytics, machine learning, and simulation-related services. Now, it's organic. It's living organism. Okay? Railway system is no more just a machine. It's like becoming like a robot. They can think by themselves. They can communicate among the trains. They can communicate between the train and the station and infrastructure and so on. So this is about digitization. Please, next. Okay, this is kind of just to have a light session about this. So about, Kelana Jaya line, LRT Kelana Jaya is driverless. It's driverless. Okay? So which means you don't see the driver. But you trust the system. Okay? It's just like the autopilot in the aeroplane. So you trust the system. So this is, again, the good thing about digitization. Next, please. Okay, these are some of the examples where digitization in railway in practice, and there are many, many, many companies in the world doing this. Number one, for example, the top one is about, okay, I'll just go, condition monitoring, for example. We have sensors in many places, okay? And those sensors give you the data real time, okay? So you have this again, the speed control, the brake, and so on and so on. These are the platform that makes the train alive, organic. Okay, next please. Okay, these are some of the smart operations which I mentioned. Okay, in terms of operational efficiency, it optimizes the fleet's operational performance. So they have, when you talk about fleet, it's the train sets. Okay, so we manage those train sets to ensure the service are not interrupted. Okay, so we have in Malaysia, in terms of operator, KTMB, Prasarana. Prasarana, by the way, manage LRT, MRT, monorail, okay? And KTMB manage the intercity, ETS, and also commuter, and also some freight or cargo. So now, this operational efficiency is about making those work as efficient as possible. You know, the best in terms of operation, no delay, is which service in Malaysia? Name it. ERL, ETS, commuter, what? The best is ERL. Okay? The punctuality rate is almost 100%. Almost 100%. And if you visit their depot, then only you know Tabit. And how do they manage? This is about operational efficiency. And this is about operator performance and vehicle performance. Everything is integrated. So ridership analysis. Ridership analysis is where there are certain routes that are not really congested. Some are very, very congested. So how do you plan your train service? And the other one is about energy efficiency. Now, this is another topic which I'm going to discuss in a bit. Okay? This is about people talking about energy efficiency. Okay? What alternative? What kind of technology or system that we can use? Next, please. Okay, this is about the VR and AR. Okay, virtual reality and augmented reality. So this is you can read. You do have this in your ebook. But what I'm saying is that on that corner is not a train. That is not the actual train. That is VR. Okay? So it's no train, but they are discussing on it. And you can zoom in to the very part where you want to modify, redesign, or whatever. Okay? So, next please. Okay.
European Rail Traffic Management System.
Okay. This is about ERTMS, European Railway Traffic Management System, which is, it is practiced now in Europe, and this is what we are going to have in Malaysia. Okay? Okay, please.
The European Rail Traffic Management System, ERTMS, is currently the world's most advanced in-cab signalling technology. It replaces existing analog communication systems and line-side signals with wireless technology and an in-cab computer to operate trains more affordably, safely and efficiently. Instructions, including line speed, are sent wirelessly from a signalling centre to a computer on board an ERTMS-equipped train. The onboard computer will process the information to tailor the speed limit and the braking distance according to the profile of each train. Each train's computer will pinpoint its exact location through an electronic beacon, also known as a balise, installed on the railway track. Information is transmitted back to the control centre at regular intervals to confirm the train is travelling according to plan. If required, the built-in train protection system will take control and automatically prevent the train from travelling too fast or getting too close to another train. ERTMS improves safety. It provides a fail-safe system to guard against the potential risk of human error. ERTMS brings savings to the railway. The costs of installing and maintaining the railway will be lower, as line-side signals will not be needed. ERTMS can assist in boosting capacity. The railway can potentially run more trains as the system provides greater flexibility to tailor train movement. It improves performance. ERTMS replaces life-expired railway infrastructure dating back beyond the 60s, significantly improving the infrastructure's capability. ERTMS is the most advanced train control system in the world and is increasingly being adopted by world-class railways globally. It was successfully brought into operation in March 2011 on the Cambrian lines between Shrewsbury and Aberystwyth and from Machynlleth to Pwllheli. Network Rail and its industry partners have a long-term plan for Britain's railway. ERTMS is a major feature, and by the early 2020s, several major main lines connecting some of our biggest towns and cities will benefit from this unique, cutting-edge technology.
So this is ERTMS. The standard is becoming a standard, And this is what we are going to get in our ECRL. Okay, I believe that is what we are going to get. The high-speed rail will also use this. Okay, because this is a kind of an advanced standard that will be used globally. Okay, okay. This is something else about train collision avoidance system using RFID. So now, one of the big events or incidents that we try to avoid is train collision. Maybe in Malaysia, we don't see much about train collision because our headway is not that short. Maybe commuter is about 15 minutes. LRT is about 10 minutes or 8 minutes during peak hour. But you're talking about a headway of 90 seconds, this is very much a problem. Okay? So this is something to do with vehicle-to-vehicle communication. So this is using RFID, which is, RFID is without the loss, line of sight. Okay? So like the RFID that we use now in our car, okay, touch and go, you have this smart tag, and now we have this RFID. So you can just pass through and everything is recorded. So everything is communicated, just not recorded, communicated, and there will be some, information sent, retrieve, and send back. So this is the system. You have this RFID reader, you have this antenna, and you communicate. You see this between trains, radio communication, and also you send it to the station. Okay, next, please. Okay, the next topic is on energy. I'm sorry, I'm going to have to rush a bit because there are a lot of things that I want to discuss. But anyway, this is about faster and greener. Now, again, historically, trains is considered dirty because of the soot, yeah? And because of the noise, okay? So it spoils the environment, the shaking, okay? The vibration. So all those are nuisance to the environment. So let's go to the next slide, please. Okay, so these are some of the energy efficiency success stories, okay? And some of it is applicable in certain countries, certain regions, and some are not applicable. So we have these fuel cell trains, supercapacitors, wind, and solar. So if you look at the graph, okay, if you look at the graph, it shows energy available in a vehicle and also the mass of energy source. So this is some comparison, which I'm not going to discuss in detail, but in class we do discuss this as an alternative. So you have these batteries, fuel cells, okay, which is real, it's coming, okay? The supercapacitors is already here. Can we have the next slide, please? Okay, look at this supercapacitor. Okay, can you stop for a minute? I'm just going to give some info. Supercapacitor was developed by CAF in Spain. In particular, Andalusia, Seville, and so on and so forth. So there, in Spain, they have many historical monuments. People go and visit all those buildings, historical buildings. But then they have these trams with the catenary above and the lines, electrical lines above them. So it spoils the scenery, okay? And also it consumes electricity quite a lot. So they come out with this innovation of supercapacitor. So this is an innovation. You save energy, you save the environment, and you save the scenery. Okay, so those buildings are intact, and they want to see the buildings, not the cables. Okay, yes, please. Okay, here are some of the clips about this hydrogen fuel cells, about wind power, solar energy, and so on. The wind power, you know, Netherlands, there are a lot of winds. So they are now using wind power for their, I think it's LRT. Yeah? So they are using that because they have a lot of winds. The speed is enough for them to generate the energy, okay? And some places where there are a lot of sun rays, so they use the solar. Okay, next please. Okay, now what I'm going to show you now is what the European railway were thinking back in the 2012, 2013, and so on. So this is where we need to look at them for us to plan the future. So these students here, railway, you have to bear in mind about you have to have this futuristic mind. What is the new technology that is already here, and what would be the next technology that so when you go in the railway industry, you will be able to advise the companies on what technology to really venture. Okay, next please. Play.
Imagine the railway in 30 years' time. As a result of the innovations developed in Shift 2 Rail's innovation program for rolling stock, trains are constructed from lightweight materials and are energy efficient. They make use of intelligent equipment and innovative traction and braking systems. They monitor themselves and the track. So how did this passenger manage to get a seat on a busy train service? It's all about capacity. The railway will be highly automated. Real-time traffic management and monitoring of the trains will optimize the performance of the network. Thanks to the technology developed in the Innovation Program for Advanced Traffic Management and Control Systems, trains will run with a safety zone that is not fixed with trackside signals but moves with the train. Trains tell the traffic control system where they are, and the control system tells them what to do. This avoids stop-start operation, saving energy. Trains travel closer together, greatly increasing capacity safely. Every stage of every journey sees the train in the right place at the right time at the right speed, ultimately getting customers to their destination on time. The Innovation Program for IT Solutions for Seamless Multimodal Transport will develop cutting-edge communication technologies to share data across transportation networks. Smart devices deliver customized real-time information to passengers, and the responsive rail system will redirect passengers in case of network disruptions. There is less need for ticket offices, reducing congestion at stations and speeding up journeys. Integrated door-to-door travel itineraries and tickets make passengers' journeys seamless. Solutions developed in the Innovation Program for cost-efficient high-capacity infrastructure will make European railways even more sustainable. Most of the network will be electrified, giving access to secure low-carbon energy. Trains using less power and causing less wear to the tracks will create an affordable and sustainable branch system. On the outer reaches of the network, energy storage systems will be used to power trains. These trains will reduce reliance on fossil fuels, charging intermittently at stations and overnight. Technologies developed in the Freight Innovation Programme will see the freight trains run smoothly through the network, providing EU industry with a reliable, efficient and competitive service. This is enabled by a control system that reconciles the different needs of passenger and freight trains by balancing demands on speed, capacity and energy. Freight trains travel unhindered at night because infrastructure maintenance is optimized. Improved rolling stock and infrastructure technology means significantly less vibration and noise, reducing the environmental impact of night running. Assets monitor themselves and each other. Sensors on trains send information on track condition back to data centers, leading to preventative maintenance. To deliver this vision, we need to think about the railway as a complete system, and we need innovation throughout. With the dedicated long-term research and innovation support and investment of both the European Union and the rail industry, the technologies developed in Shift to Rail will meet customers' needs by delivering an affordable, safe and sustainable railway, which provides both high capacity and reliability, and which is accessible to all. And with this joint undertaking, the rail industry can promote a culture of innovation, learn from other high-tech industries and roll out new technologies. The railway that emerges will be ready to cope with the demands of the 21st century and promote the worldwide competitiveness of EU industry in manufacturing and running the most sustainable transport mode.
How do you ensure you protect the environment? Give me, there are many there, many. Give me one. Low carbon, low. Okay. Number two. What about ticketing? What's so special about this new kind of ticketing? It's paperless. It's contactless, and we talk about multimodal. Okay? Now, imagine you have this, you have to pay for LRT, you have to pay for monorail, you have to pay for ERL, you have to pay another one for, say, ETS. So then you have this now, you have this My 100, My 50. Okay, fine, good. But this is contactless. Okay, it's about your phone, just your phone. That's enough. Now we have this e-wallet now. Okay, this is a kind of application that we have, and this is going to be the norm. Okay, for those that are already retired or going to retire, so this is something that we need to familiarize. Okay, no more. Maybe in the 5 years' time, there wouldn't be any counters, or maybe very less counter to issue your tickets. You just, everything is go through, and then that's it. All right, so next, please. Now, I would like to bring to the discussion about high-speed rail, because many people ask me, okay, including foreign journalists, what do you think about the high-speed rail project, after that kind of a cancellation kind of thing? My answer is quite simple. High-speed rail is imperative. You have no choice. You have to go with it. Otherwise, we are going to go back maybe 50 to 60 years. So we are now already lagging behind Japan, which initially had 12 years difference. Now we have about 100 years of difference in terms of technology. If we don't go forward with this high-speed rail project, we are going to go back 50 years. Now that would be my answer. But if you look at what I'm going to show you now, maybe you can agree with me. Okay? So this is some kind of, people now are looking at high speed to hyper speed. Now, the category for high speed, there are various categories, but I would say in general, high speed is 250 kilometers per hour and above. Okay? Even in the UK, they don't have high speed, except for the tunnel. Now they are arguing in the parliament about this HS2 project. London, Birmingham, Birmingham, Manchester, Sheffield, and so on and so forth. So they have this multi-billions project pounds for that HS2. So now, this is about high-speed rail, and I'm going to show you some figures. Have a look at it, and what do you think about it? Next, please. And what do you think about it? Next, please. So these are some of the figures about speed, okay? Now, talking about kilometers is another thing, okay? China, in 1990, they have 0 high-speed line, 0, okay? Now, in average, this is the figure I got is from 1990 to 2015. In average, the increment for high-speed rail, not to say normal rail, high-speed rail, the increment per year average for China is 2,200 kilometers per year increment. So that's why China now is the most populated countries in terms of high-speed rail. They import the technology from Germany and elsewhere. After 10 years, they developed their own high-speed rail in terms of the rolling stock, the system, and so on and so forth. And in 2015, China has a factory making rolling stock in the United States of America, in Pennsylvania. So imagine how China has progressed. Okay, now if you compare the speed there, now this is average, not maximum speed. This is, if you look here, it's start to stop. What is start to stop? At the station, it starts and the next stop. What would be the average speed? Okay, you can say from 0 to certain speed and then 0 at the stop. So if you look in the league, number 1 is China. And the speed is 317. So not many above 300. This is start to stop, okay? Not maximum speed, okay? I'm going to show you the maximum speed in another video next. But anyway, you look at China, Italy, France, Japan, Spain, Taiwan, Germany. Okay, if you can, you look, 317 kilometers per hour, average speed of 2 trains at the top of, okay? Now, please go to the next slide, please. Now, the next slide shows you, we continue the league, okay? So you have this, what was that? Turkey, Russia, and, below that is United Kingdom. So United Kingdom is not as fast as the other countries. So now that's why they are eagerly trying to have this high-speed rail in UK. Okay, Austria, Saudi Arabia, Norway, Netherlands, and so on and so forth. Uzbekistan, Malaysia, no way. So the highest speed is, for our nation, is the ERL, 160 kilometers per hour. Although it can go for 180. Okay, next please. So these are some of the runs that they did. Again, you look, China, okay? Paris, Lyon, Seoul, and so on and so forth. Okay, next please. Okay. This is trains concerning the speed. Yes, please play.
Maximum speed of high-speed trains has been gradually increased in the past century, and the hunger for higher speed never stops as it's proven beneficial in improving people's productivity, lower carbon footprint, as well as smaller mortality rate compared to other modes of transportations. That's why maximum speed testing on new train prototypes is held occasionally. These are 10 fastest train models in the world. 10th place, 300X. 300X, or Class 955, is the Shinkansen's trial model introduced in 1992. 6 total units were produced by 4 different vendors with little variations among them. In July 1996, Unit 6, which is the last unit, managed to clock 443 km per hour in test running and became Shinkansen's fastest train record, which still stands today. 9th place, Transrapid 07. Germany's Transrapid development began in 1969. 19 years later, the 7th generation model registered maximum cruising of 450 km per hour along 1-year-old Ermsland test run facility. Until today, it remains the fastest rail record in Germany. 8th place, CRH 380A. China relied on foreign trains for the first generation fleet. In early 2008, the development of homegrown high-speed trains began with a target of commercial speed of 380 km per hour. Hence, the model was named CRH 380A. On December 3, 2010, the train reached 486.1 km per hour during a 220 km test run. 7th place, CRH 380BL. Derived from Germany's Siemens Villaro, 100 units of CRH 380BL were built locally by China Northern Railways Company. During a subsequent test on January 10, 2011, these 16-car train sets broke China's own locomotive record of 487.3 km per hour. That's about 1.2 km per hour faster. Sixth place, Transrapid SMT. The only commercial version of Transrapid train began its operation between Shanghai International Airport and Longyang Road Station with travel distance of 30 kilometers. Albeit able to reach 501 kilometers per hour, the daily operating speed is capped at 431 kilometers per hour, which was already the fastest commercial speed during that time. 5th place, TGV Atlantic. TGV Atlantic is the second TGV model introduced by Alstom in 1989 for France's high-speed rail service. On a sunny day of 18th May, TGV Atlantic train set 308 cruised along LGV Atlantic railway line at 515.3 km per hour. That was the fastest commercial train model on the planet. 4th place, ML500. Miyazaki Test Track was built at a length of 7 kilometers with monorail track upon opening in 1977 but changed to U-shape in late 1980. The first trial train model, ML500, was built specifically to become the first ever train to break 500 km per hour speed mark. 3rd place, TGV Post. A series of test runs called Operation V150 were conducted on the LGV East prior to its June 2007 opening using a specially modified train. On April 3, 2007, top speed of 574.8 km per hour was reached, making it the fastest wheeled train on the planet. 2nd place, MLX-01. Yamanashi Test Track is a 3rd generation track specifically for testing maglev train at a length of 43 kilometers. Upon its completion, MLX-01 trains were introduced in 1997. From that day, continuous efforts were made by exercising serial test run for years. In 2003, the train clocked 581 kilometers per hour, which was the fastest train ever during that time. 1st place, LO Series. When the MLX-01 service was terminated in 2011, JR Central, the body which governs Japan research in maglev train introduced a new generation train model called LO series. LO series was shown to public in November 2012. On April 21st, 2015, a 7-car train set a new land speed record for rail vehicles at 603 km per hour. It is the only rail vehicle ever surpassed 600 speed mark.
Okay, this is about speed. Okay, now people are now comparing high speed. So what about us? Do we need high speed? Okay, okay. So there was some yes, yeah. But it's a matter of, because investment is very, very big, okay? Very, very big. So you have, when you talk about this high-speed rail between KL to Singapore, so the one that initiated the idea was thinking there is a high volume of travelers. The shuttle service, the plane from KL to Singapore is huge. So if you provide an alternative, people will go for trains, just like in developed countries. Okay, they prefer to go if there is an alternative, and if it is slightly cheaper than the flight fare, they will go for trains. Because in trains, again, number one, it's about door-to-door time, and again, it is on the ground. Okay, but how do you ensure at that high speed you maintain all the criteria that you want? Safe, comfortable, and so on. Okay, so next please. So these are some of the technologies that has been developed while developing the high speed, getting for higher speed. And when I was in UK, and Prof. Dato Wahid was there, maybe a witness, or Prof. Razai, of Prof. Ahmed. In the 80s, we have this AT125, okay? The train in UK, in those days was British Rail, they call it. They keep advertising at the curve, the train can go to the speed of 125 mile per hour at the curve. Okay, so how do they manage? That was in the 1980s, okay? So, but then if you look at this kind of I'm just giving you some example here about the suspension system. At curve, so this is a bit technical, but not so technical. On the road, if you travel, on the road, you call it cornering or bends, okay? And you have this super elevation, from here, super elevation. In rail, we call it cant angle, okay? Because you have to maintain, in cars, it's okay because 4 cars on the flat road. In rail, you have to maintain on the rail. Now, that's more difficult, okay? From the structure, civil structure side, you have to provide this cant angle. For the mechanical side, you have this kind of a tilting kind of thing. Now, tilting is to compensate that cant angle. Now, cornering, you have to have kind of super elevation. Similarly for rail, so you have this kind of a cant angle. But you have to remember, this is on steel wheel. So you have to provide those kind of suspension. We call it active suspension. You have this primary suspension and you have this secondary suspension. Everything is controlled actively. So this is where this active suspension becomes important. So those are some of the things that are being developed and still being developed to reach for that speed. So speed is the motivation for the new technology that is developing. Okay, next please. So this is again another one. I want to show on the top, okay? Now, on that top, you have this kind of, pantograph, catenary. So this is again another innovation, okay? So it goes down and it goes up when it is necessary. This is to reduce drag, okay? So again, there are some, this is about the tilting mechanism that I mentioned. Okay, next please. Okay, now this is about Hyperloop. So students, Hyperloop is different technology. Okay? Why is Hyperloop considered a railway system? Anyone? Okay? Because there are no rails. There are no rails. Hyperloop, no rails. But it is considered as railway. So please.
Billed as the fastest way to cross the surface of the Earth, Hyperloop represents the greatest leap in transport infrastructure for generations. With passengers sitting in pods that travel at airline speed through pressurized tubes, using electric propulsion and magnetic levitation, the concept promises to slash journey times between major cities from several hours to a matter of minutes. Whilst it may feel like science fiction, Hyperloop is now on the cusp of becoming a reality. This is the story behind the concept that's about to revolutionize our world. Hyperloop was first conceived in 2012 by Tesla and SpaceX founder Elon Musk. In a white paper released the following year, Musk set out his vision for a futuristic, super high-speed transportation system that would see passenger pods move through a partial vacuum in steel tubes, addressing the two key factors that slow down conventional vehicles: friction and air resistance. Exploring a potential route between Los Angeles and San Francisco, Musk believed that his concept could slash the 8-hour bus ride, 4-hour train journey, and convoluted 3-hour air travel experience between the two cities to just 30 minutes. Under Musk's first Hyperloop proposal, he suggested that compression fans would move air around the passenger pods to minimize drag and create air bearings beneath them, floating them off the surface of the tubes. It should be noted that Musk's early Hyperloop concept is not a million miles away from Isambard Kingdom Brunel's atmospheric railway that ran between Exeter and Plymouth in the UK from 1847 to 1848. That system moved carriages with pressurised air. The air was extracted from a pipe that ran between the rails by pumping stations situated roughly every 3 miles along the route, creating a vacuum. A piston contained within this pipe was connected to the train, which pulled it forward. Despite its initial success, the leather flaps that made the vacuum pipes airtight soon began to fail, causing air to leak from the system, and Brunel's railway was abandoned. With an estimated price tag close to $6 billion, Musk's first Hyperloop concept never came to fruition. But the impressive idea and potential to link cities in such a direct way sparked intense interest. From inception, Musk had always stated that the concept of Hyperloop would be open source, and he actively encouraged others to come together and develop the necessary technology independently from his involvement. This led to the formation of several startups and student teams developing various aspects of Hyperloop technology with varying degrees of success. Now, several fully fledged companies are making significant strides to bring Hyperloop systems into reality. Hyperloop Transportation Technologies, or HTT, are making aggressive advancements and recently constructed a full-scale test track in France. But the clear leaders of the pack in the current standings are Virgin Hyperloop One. Virgin Hyperloop One are on track to achieve their bold ambition of bringing a Hyperloop system into operation by 2021. Originally formed in 2014 as Hyperloop One, the company was rebranded following a significant investment from Sir Richard Branson in 2017. Deviating slightly from Musk's original plan, Virgin Hyperloop One's technology combines two basic principles. The first is magnetic levitation, or maglev, a technology already used in monorails to lift the passenger pods and move them along their rails. Magnetic levitation uses two sets of magnets, one to repel the train from the track and lift it upwards, and the other to move the floating train along the track at considerable speed with reduced friction. The second principle is the use of a low-pressure, vacuum-sealed environment for the passenger pods to travel through. By removing most of the air from the tubes and having no contact with the ground, the pods face little to no resistance as they move. Air pressures inside the tube are equivalent to flying 200,000 feet above sea level. Such an environment enables the pods to reach speeds of over 760 miles per hour using very little energy. By virtue of being in a tube, the system is protected from the weather and can operate in almost any climatic conditions. Virgin Hyperloop One's system is controlled by advanced software that ensures acceleration and deceleration occur gradually, going relatively unnoticed by those travelling inside. Having built a 500-metre track in the Nevada desert, Virgin Hyperloop One have carried out several tests, focusing on individual aspects of the system, and a complete full-scale systems test in May 2017. The propulsion, braking, levitation and vacuum systems are all performing well, and the team have achieved a top speed of over 240 miles per hour to date. To inform their plans for developing a fully operational network that is affordable for all, Virgin Hyperloop One launched a global challenge to find the routes best placed to benefit from Hyperloop technology. With over 2,600 entries, the field was reduced to just 35 potential locations, with each entry enjoying strong support from governments and urban planners. With 10 winners across 5 countries, Virgin Hyperloop One are now working in partnership with each of the locations on how best to deliver the Hyperloop technologies in live networks. In February 2018, the firm unveiled their first prototype passenger pods for the Dubai to Abu Dhabi route, a network that would drastically slash the car travel time between the two cities from 2 hours to just 12 minutes. The advantages of Hyperloop are considerable. Like train stations, Hyperloop stations called portals are planned to be located within inner city areas with easy links to existing transport infrastructure. This gives Hyperloop systems a distinct advantage over air travel, where airports tend to be located beyond city limits with fewer accessibility options. Additionally, the system is being developed to function on a turn-up-and-go principle, without a lengthy check-in process, and with accelerated, advanced security checks. Another clear benefit is its speed. If Hyperloop could significantly reduce the travel time between cities, it could be possible to live in a completely different city or a part of the country from where you work, with a commute no dissimilar in length to the one you perhaps take today. This opens up a wide range of housing and employment opportunities, with people no longer having to live close to where they work. It could also take pressure off our cities, where infrastructure is often still catching up with development, and where house prices have become unattainable for most. With speeds rivaling aircraft, and 9 of the top 10 busiest air routes in the world being domestic, Hyperloop has the potential to completely revolutionise the way we live, work and travel. A Hyperloop system requires very little energy to propel pods through its tubes, as the vacuum environment poses little resistance. As such, the systems could be powered by renewable technologies such as solar and wind, offering a considerably cleaner alternative to air travel. When you consider the prospect of people being propelled in tubes across the Earth's surface at near supersonic speeds, there are a number of questions that instinctively jump to mind. Perhaps the first is the impact of a potential break or breach in one of the tubes, possibly as the result of an earthquake or external impact. Virgin Hyperloop One explained that they have addressed this by constructing thick steel tubes that are extremely difficult to puncture or break. Additionally, the tubes are engineered to withstand changes in pressure and air leaks while maintaining their structural integrity. Theoretically, a sudden influx of air into one of the tubes would simply slow the pods down due to the increased air resistance. The pods could then be directed to the next portal via an auxiliary power boost. There is also the ability to section off parts of the route and to repressurize sections where significant emergencies occur, and all pods are expected to be fitted with emergency exits. Externally, Hyperloop systems will largely travel on elevated, seismically designed pylons that are able to move and flex independently of one another, minimizing damage in the event of a major ground shift. Sensors along the route would instantly report issues to the system's control center. In answering the natural safety concerns raised, Virgin Hyperloop One also point out that millions of people already travel at high speeds in metal tubes every time they take a flight, and that numerous concerns surrounded the use of jet aircraft when that mode of transportation first came to prevalence. While the idea of Hyperloop may seem far-fetched, when you consider the industrial progress made in the past 200 years, the current rate of technology adoption in our societies, and the significant advances being made by Hyperloop companies around the world, this incredible new transportation system looks set to become part of our everyday lives in the very near future. If you enjoyed this video and would like to get more from the definitive video channel for construction, subscribe to the B1M.
So you don't see the trees and so on and so forth. But 30 minutes from San Francisco to Los Angeles, which is about 1,000 kilometers, in 30 minutes. Just imagine. Okay, now that will be the future. Okay, so if you are still arguing about high-speed rail, people are talking about Hyperloop. Okay, so this is, what I want to show is actually to entice the students. Okay, look, railway technology is not that something we used to know. Railway technology is very advanced. I hope the students will take up this challenge, okay, to be at par with the research being done in the other developed countries. Tak dapat ke? Boleh? Okay. Tak apalah, okay, I'll proceed. Maybe after this we can show, or you can go to the website later. Now this is now the idea is Hyperloop 30 minutes, 1,000 kilometers. That's supersonic. Okay. It's very fast, okay, and it's going to be very expensive, yes. But again, if you talk high-speed rail in China, very underdeveloped in the 1990s, and the high-speed rail challenge. Now they are exporting their technology to the other countries. So they are becoming an economic power even in terms of railway technology. Okay, so this is about rail automation. I'm going to go fast about it because some of it you have already seen in the video. Now, automation is without human intervention. Okay? It's basically without human intervention. In terms of the control, in terms of mobility, it's without human intervention. So instead of, I will go to the last one, it's about time-based to condition-based. Now, about maintenance, okay? Maintenance normally is about time-based. After a certain, we call it certain RPM or certain miles or certain kilometers, you do some maintenance on certain things periodically. But in terms of condition-based maintenance, it's about the sensors that you put in and the data that you acquire, you store, and you do the analysis. We call it data analytics. So again, this is where computer science comes in, okay? Next, please. I think we are running short of time. So these are some of the key drivers of rail automation, okay? In terms of capacity demand, in terms of safety, in terms of integrated, okay. One thing about seamless journey. Do you know what seamless is? Seamless. Seamless. Dr. Zul ada kat sini. Kalau, if you have a cut, okay, or a tailor, okay, so you have these two parts you join together. How do you join it? Okay, you put some, some string, some needles, and you put it. Okay, now, over time, you can see them, okay? You can see those marks. Seamless is, you don't see it. It's as though there's nothing discontinuous about it. Everything is continuous. So this is what we call as a seamless journey. From one mode to another, how do you ensure that you can, to my own experience, okay, in Japan, using that phone, okay, they will advise you which door to stand. When you exit, they will advise you to take right or left turn, which stairs to take, up or down. So everything is very much like Waze, but very much personal. So this is something about the seamless journey where you can get connected real time. If there's delay there, you know what will be the alternative. So this is about seamless journey. So this is about efficient integrated journeys. That is just one of them. So the other issues, maybe we can discuss it in other platforms. So next, please. Okay, this is where the system is becoming smarter. This is what we call it organic, okay? Think by itself, do by itself without instruction from others. So they can communicate among others. So this is, again, large number of sensor-based data collection points. So this is for electrical engineers, for an electrical faculty. So for computer faculty, this is the way forward, okay? Predictive maintenance and so on and so forth. Okay, next, please. Okay, this is some of the convergence of technology. So we have so many technologies around. Railway need them all. Okay, next, please. All right, so this is, again, a video showing Europe as a united union, how they plan for the future. Yes, please. UTHM, among the M-tone, the niche area is transportation. So it is a right place. From there, it seems there's a great potential for UTHM to become great, very, very, prominent in transportation. If you look at the strategy, so it needs not just mechanical, not civil, it integrates everything. Okay, so this is where all the various disciplines should come together and push for our national railway agenda. Okay, so I'm part of this 2030 Future Rail for Malaysia group. So we have planned for 2030. I'm going to discuss very briefly in a minute, a few minutes. Okay, next please. Okay, these are some of the challenges regarding IT security. This is about cyber security. Maybe this, from the computer science, you may need to look into this, because due to the railway innovations, there will be some sensor technologies with real-time data analysis. So this is a challenge, okay, real-time data analysis that might be, used for, bad use by anyone. Okay, how do you ensure that that data is safe? Okay, and what you get is correct, all right? Complex rail system design. Railway is no more simple. It's very complex. You have seen some examples there, very complex. So how do you ensure the increased probability of design in errors? So we go for SIL4, okay? SIL4, which is safety integrity level 4, which is something like, I don't know how many millions of, one per maybe how many millions of failure. So high-speed rail going to hyper speed, so we go for SIL4. No SIL1, no 2, no 3, it's 4, the standard, okay? So highly interconnected system. So again, there will be some breach of information, so you have to have this higher IT security. So you want to share, but who do you share with and how good it will be used? Okay, next please. Next please. Okay, now go forward. Okay, this is about, again, industry. So this is not much on technical, but this is more on the business model, okay? So we have this integration of vertical and horizontal integration in terms of supply chain. So for those who are doing blockchain, so this is where it is needed, okay? In terms of data analysis, data analytics, and where to apply them. So horizontal, if you look there, we have these various levels, okay? In terms of railway, you have these component makers, you have this system integrators, and then on top of that will be the operators. So how do you manage all the different companies, different industries at different levels? So again, this is where consolidation comes in. Consolidation is synergy, working together. No more working in silos. Data sharing, okay? And who do you, and money-wise, you have to consolidate. Okay, next please. I think I'm going to, okay, again, this is about partnership. In terms of apps, okay, many people can develop their own apps, okay? So people are very creative, okay? In terms of ensuring your transportation or your mobility to be, in advanced stage, you have to develop this. Okay, this is about the ticketing, okay? Pay as you go now is about just go through and everything is taken out from your bank, okay? Okay, next please. This is just a comparison between the increase in terms of traffic, passengers and also freight in between those years. So in terms of railway usage, globally, it's increasing very, very fast. Okay, next please. So what about Malaysia? So we have here KTMB, Perdana, we have Techmark, we have a few from the industries. Thank you very much for coming. So I appreciate that very much. And the rail industry in Malaysia, where are we now? Okay, next please. Okay, so this is, we very much depend on the foreign OEMs and very small market focus. This is about consolidation, okay? And to the next level, this is where I think we are quite strong in terms of MRO, okay? Maintenance, repair, and overhaul. We can do it, okay? We can do it. Albeit maybe the new technology comes in, but we still worry about the knowledge transfer. But then those issues are now being tackled. And after that is manufacturing and assembly. So we have this Komi Engineering, which manufacture train sets. Malaysia boleh, okay? SCOMI is one example. And no. So on the tax level is on the design, engineering, and system integration. This is, we are quite lacking. So you guys, the students, we need to go to the upper level now, okay? Not enough for MRO, not enough for manufacturing and assembly. You have to go up for the design, engineering, and system integrators. We now rely very much on foreign experts. So by 2030, we envisage the integrator and exporter of light rails with speed of less than. Again, this is where we follow suit from China. China, 1990, 0. By 2015, they have a factory in US. Not in Malaysia, in US. How did they do it? Okay, next please. Okay, this is some Minister of Transport. This is new, this is current. I just came back from the workshop a few months ago, maybe 2 months ago, so this is what they are planning. Next please. Okay, this is some of the projects, okay, so that will be the history, and those are the new projects, the future one. Okay, next please. Okay, I'm going to just talk a bit about Malaysia, where we stand. So the project about the Singapore-Kunming rail link, Malaysia is a very, very important place. Geographically, demographically, we are very, very important. So this is where, this is about Trans-Asia, okay? So this is, again, the Trans-Asia Railway Network, which is going to happen. Okay, next. So this is, the Dr. Joe? Okay. So the capital of Indonesia will move to Kalimantan Timur. Somewhere there, right? Somewhere there. So again, new rails are coming up. Okay? So this is, the project of plenty. You guys don't worry, okay? In Malaysia, there will be a lot of work, and in future, there will be also a lot of work in the ASEAN region. Okay, not to mention Middle East. Okay, next, please. Okay, these are some of the projects. Again, this is from TDA, Technology Depository Agency, from the Ministry of Finance. This is in terms of investment that is coming. Okay, next, please. Okay, and this is in a bit more detail on the cargo side. Okay, transportation from Singapore to Kunming, and this is also related to One Belt, One Road China initiative. Next, please. Okay, in Sarawak, you have this Sarawak Railway. That will be, the target is 2030, okay, underscore. Next, please. So next, please, high speed. Okay, this is about the integration of rail, okay, just like we have some simple, small case is a TBS, okay? Terminal Bersepadu Selatan. So this is a big one, okay. So we are going to have this Bandar Malaysia. You know what Bandar Malaysia is? The old Sungai Besi Airport is going to be Bandar Malaysia. So it's going to be the big hub for transportation. Next, please. So these are some of the current and challenges. Next, please. I'm going to, due to time shortage, I'm not going to discuss this, but you have this in your e-book. So these are some of the drivers of change in Malaysia, because I am part of that Future Rail 2030, so we discuss this, so this is what we come out, okay, in terms of policy, in terms of technology, and human capital development. So this is where ICOA Rail comes in, okay, Industrial Center of Excellence of Railway in Malaysia is in Pagoh, here. where I am the head. So this is the technology and human capital development. So this is UTHM's role. Next, please. So again, there will be multimodal, market, okay, connectivity and tourism. Next. Some issues there. Next, please. Next, please. Okay, some of the issues. Next. Okay, these are some of the research in Malaysia that is going to be conducted. Some of it is being conducted now, and some of it is going to be conducted in the near future, okay, in terms of magnet technology and so on and so forth. Next, please. Okay. My hope for UTHM, although I'm going to retire very soon, okay, but this is what I would like to have in Malaysia, or rather in UTHM, maybe in 5 years' time, we should be something like this, okay? JTRI is the Japan Technical Research Railway Institute, okay? There should be another one, JTRI, Japan Technical Research, Railway Research Institute. Okay, please play.
Railway Technical Research Institute has been continuing to engage in the research and development of railway technology for over a century, since its establishment in 1907. Since the institute was moved to its current location in the Kunitachi area of West Tokyo in 1959, RTRI has played a central role in the research and development of the Shinkansen, the world's first high-speed train, as well as maglev, the magnetically levitated transport system. In 1987, the Japanese National Railways was privatized and divided into several companies, and RTRI became an independent organization, although maintaining close ties with the railway companies resulting from the division. In 2015, a vision for RTRI called Rising was formed, aiming to develop innovative technologies to enhance the rail mode so that railways can contribute to the creation of a happier society. This vision focuses on 3 missions. 1. Intensifying R&D activities. 2. Fulfilling our tasks using the best science available in an ethical way as an independent and impartial research body. And 3. Becoming a leader of the world in the field of railway technologies. In R&D, the Institute aims to address challenges that demand innovation, promote research in fields where RTRI has significant advantages, explore research frontiers, advance interdisciplinary research projects, and advance fundamental research. Based on the future vision of RTRI, execution of the master plan called Research 2020 was started in 2015. RTRI covers a wide range of research fields such as in vehicle technology, civil engineering, electrical engineering, information and communications technology, material science, environmental engineering, and human science. RTRI specialists of each field are cooperating with each other while maintaining their uniqueness, and are working on the R&D for the future of railways, development of practical technologies, and basic research for railways. And the main R&D objectives of RTRI are improvement of safety, cost reduction, harmony with environment, and improvement of convenience. Now, the R&D activities of RTRI will be introduced along these 4 objectives. Entrusted with passengers, the most important responsibility of railway operators is maintaining and improving safety. RTRI has been promoting a broad range of research projects to improve safety, such as the analysis of derailment mechanisms and development of preventive measures. The evaluation of safety and development of preservation technologies against natural disasters such as earthquakes, tsunami and crosswinds, and the evaluation of passenger safety and passenger behavior in the event of an accident. In managing large infrastructure, it is important for railway operators to reduce costs in various fields such as construction, manufacturing, inspection and maintenance. RTRI is working on projects to reduce cost while ensuring safety, such as the development of monitoring systems using information and communications technology (ICT), improvement of maintenance efficiency, infrastructure diagnosis using image processing technology, technology to reduce maintenance costs of ground facilities, and disaster-resistant structures. Railways are an environmentally friendly transport mode. RTRI is promoting energy conservation utilizing superconductors cultivated from the development of maglev vehicles, technology for clean energy, and the development of fuel cell railway vehicles that run on hydrogen. And the Institute is working on innovative research and development aiming for environmentally compatible railway systems, such as in the analysis of and countermeasures for trackside noise and vibration phenomena. RTRI is aiming to achieve more comfortable and convenient rail travel. For example, the Institute is conducting R&D on measures to enhance convenience in stations by simulations and experiments of passenger flow, evaluating ride comfort by simulating vehicle vibration and noise perceived by passengers, and developing damper systems to reduce vertical vehicle vibrations, all in order to achieve more comfortable and convenient rail travel. Strength in basic research, aiming at pioneering discoveries, is a major characteristic of RTRI in activities such as analyzing railway-specific phenomena and developing new materials. For example, analysis by computer simulations are enabling researchers to examine phenomena that were not visible until now to the human eye. Furthermore, RTRI is conducting R&D crossing over different fields of expertise, such as by developing virtual railway test tracks that integrate various types of simulations. Many testing facilities support the R&D activities at RTRI. Our institute headquarters in the Kunitachi area in West Tokyo has a 700-meter-long railway test line, a test stand capable of reproducing train running conditions up to a maximum speed of 500 kilometers per hour, a large-scale vibration testing system that can simulate ground vibrations of large-scale earthquakes on the order of 1 or 2 G, and various other testing facilities. RTRI also has testing facilities in other parts of Japan. RTRI's large-scale low-noise wind tunnel in Maibara utilizes the world's top-class low-noise performance to evaluate aerodynamic noise of railway vehicles, and other facilities conduct R&D making use of the natural environment to examine damage due to salt and snow. As an independent third-party organization, RTRI offers its expertise to activities such as investigations to examine causes of accidents and disasters and propose countermeasures, technical support and drafting of national technical standards. The Railway Technology Promotion Center at the Kunitachi headquarters of RTRI provides a forum where railway engineers and researchers can compare notes and cooperate with each other. The activities of RTRI are not limited to Japan and involve active communication of R&D information in collaborative research projects with overseas railway companies, research organizations, and universities. The Railway International Standards Center was established in 2010 to play a central role in reviewing international railway standards, coordinating with related Japanese and overseas organizations to spread railway technology of Japan throughout the world. And in 2019, RTRI will host the 12th World Congress on Railway Research, WCRR 2019 in Tokyo. This Congress will be a major opportunity for railway-related delegates from around the world to gather to exchange ideas and promote further research and development of railway technology. The railways are continuing to expand throughout the world as vital and indispensable infrastructure. By engaging in dynamic R&D activities and developing innovative technologies, the Railway Technical Research Institute will continue to contribute to the development of railways and the realization of a more prosperous society.
UTHM can be in the not so far future, inshallah. Okay, next please. So this is some of the technology development in rail in various countries, which I share the documents from our Future Rail 2030, okay, with MITE and also with this Technology Depository Agency, and the countries like Japan, Australia, and so on and so forth. So they have their own focus. Okay, next please. United States, India, by the way, is quite advanced. Okay, it's quite advanced. Ada orang KTMB sini tak? KTMB ada? Tak nampak. Tapi okay, KTMB Dewan yang kata, dia punya tapi di India, the railway in India is one of the most punctual in the world. It's the most punctual in the world. India. You may say that India, they have people on the trains, at the doors and so on, but so forth. But in terms of punctuality, this is from our KTMB friends, is one of the most punctual train service in Malaysia, in the world. Okay, so that's why India is quite advanced in terms of rail. You may be looking at certain segment of India, but on the upper segment, in terms of technology, they are quite advanced. Okay, next please. Okay, this is what we, in our 2030 vision, is what Malaysia should be, okay? A strong and sustainable business capable of satisfying the demands and the national rail transportation and competitive global player, and optimizes the use of indigenous source resources and technology, and so on. So that's why I can read. Okay, next please. So my acknowledgement to the UTHM top management, the top management, the Ministry of Education of Malaysia, the Ministry of Transport of Malaysia, Prasarana, KTMB, ERL, my HSR. My HSR, by the way, before they are being kind of, I wouldn't say thrown out, but it's kind of frozen for now. But it will reactivate quite soon. That's what I heard. The TDA, Technology Depository Agency, Ministry of Finance, which finances in terms of training our staff and also our students, and giving us the train that we have there. So this is part of their initiative, TDA and also Prasarana, and all those that have contributed directly or indirectly to the success of this event. Okay, my last word, orang putih, orang Melayu. Terima kasih. Thank you.
Thank you very much, Professor Dr. Khalid bin Hasnan, for the inspiring and informative speech. It was very interesting to know more about the trends shaping global railway technology and industry. The e-book for this lecture can be retrieved via the QR code provided at the entrance of this hall. Next, we would like to express our gratitude to the speaker for sharing his valuable knowledge and experience with us. Ladies and gentlemen, we would like to invite Yang Berbahagia Professor Datuk Technologies Dr. Wahid bin Razali, Vice Chancellor of UTHM, accompanied by Professor Dr. Ismail bin Abdul Rahman, Deputy Vice Chancellor Academic and International, to present the Certificate of Appreciation to the speaker. Yang Berbahagia Professor Dr. Khalid bin Hasnan. Ladies and gentlemen, in the ceremony, we also have special audience from Graduate Employability Enhancement Program. This program is organized by Industry Center of Excellence of Railway, ICOE Rail, and we are also informed that today is their last day in UTHM, as after this they are going to continue collecting and creating experience in Prasarana Berhad. Ladies and gentlemen, we would like to invite Yang Berbahagia Professor Datuk Technologies Dr. Wahid bin Razali to officiate Graduate Employability Enhancement Program.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Saya ucapkan terima kasih kepada Prof Khalid kerana telah memberikan satu inspirasi kepada saya sendiri yang suka train, suka kereta api, tapi yang penting adalah kepada pelajar-pelajar kita ataupun kita kata the future talent of Malaysia. Jadi saya harapkan the future is there for you. Apabila kita membangun program sarjana muda teknologi pengangkutan rail, we know for certain that the future is yours. And it is for you to develop this program into what the future needs. Of course, di UTHM kita ada jabatan pengangkutan rail. Kita juga ada on the supporting side itu untuk membantu, iaitu ICOE Rail, Industry Center of Excellence untuk rail, yang diketuai oleh Profesor Khalid. Dan inilah yang kita akan gemblengkan, dan mungkin dia akan menyerupai apa yang kita dapat lihat daripada apa yang telah disampaikan oleh Profesor Khalid tadi, iaitu apa yang ada di JTRI, iaitu Japanese Technical Research Institutes di Jepun. Kita memang ada angan-angan macam tu. We have a very strong passion for that, reflected by Professor Khalid. And we hope to that more young energy untuk memasuki industri rail ini, kerana ini memerlukan a new insight, ya? Dan saya yakin dengan adanya apa yang dipanggil oleh Profesor Khalid tadi, the future trend and also blueprint untuk rail industry di Malaysia, saya yakin that they need people like you to support. They need people like you to become the brain, not only the hands tetapi also the brains. Seperti yang Profesor Khalid nyatakan tadi, what we need now basically is the higher level for those involved in the design of kita kata untuk signalings, even untuk tracking, even untuk electrification, dan juga untuk kita kata stock, ya, untuk dia punya gerabak itu sendiri. cuba fikirkan, kita ada gerabak, 4 gerabak itu, tapi gerabak lama lah. But that's good to begin with. Saya telah naik kereta api yang ini, tapi belum lagi naik kereta api yang ini, yang shape dia mencapai saya rasa 600 kilometers per hour. So our imagination, kita punya harapan mestilah ke situ. Bagaimana kita untuk menyediakan perkara ini. Sekurang-kurangnya kita belajar daripada 2 superpowers of railway industry, iaitu China dan juga Japan. China, as shown by Prof Khalid tadi, 1990 was just ordinary. Tapi now, they are top in the list, they are top operators, dan juga they are top manufacturers of what we call a system, bukan dia kereta api saja, bukan a railway, a system. Jadi oleh yang demikian, saya ingin menyatakan how I appreciate this program is, dan how dengan kerjasama TDA dan juga Prasarana dan juga UTHM, kita mengucapkan terima kasih kepada our partners in the industries, dan with the little thing that we can do, we'll try our best. And to begin with, saya mengucapkan kira kata selamat menjalankan. Dia bukan kursus, you must put in yourself, the 20 of you that's going to have a 4 weeks, 4 weeks in industry. Hopefully it is not a kursus. This is your own responsibility to learn and to practice and to really understand. And the learning should permeate not only your minda, tetapi juga your hearts. Sebab kita memerlukan orang yang passionate. I hope you continue on, become the progressive individual yang akan membangun, keep on membangunkan industri real negara kita. Let's begin with you, and I hope that you will promote among other students, among the whole population of Malaysia, that industri real memerlukan orang yang committed, orang yang people like you, dan ajaklah mereka datang beramai-ramai untuk masuk program, kita punya program. The more I think we can plan better, sebab kita ada blueprint dan kita ada kerjasama yang baik dengan Prasarana, kita ada MOA dengan Prasarana, dan we have lots to share with. Ingin juga saya nyatakan di sini bahawa kita inginkan supaya pelajar-pelajar one day masuk UTHM, you become a professional certified signal operators ataupun designers, ataupun kita kata track designers, ataupun whatever, kita kata gerabak punya manufacturers or whatever. We need to have that very strongly. We already have untuk kita punya piloting, dan we are going to have untuk kita punya maintenance, repair and overhaul untuk aircraft. Now, the challenge is that we need more of Prof Khalid into this, dan sebab we grow old, Prof Khalid pun nak pencen, tapi we need young people. So I hope that I must thank Prof Khalid for sharing this Syarahan Perdana, and we hope that 20 orang masuk, 20 orang keluar with some extra, not only knowledge, I know that knowledge you can read from lectures, from YouTube, tapi the practical tu, itu yang sangat penting, dan saya harapkan saya ucapkan terima kasih kepada pelajar-pelajar semua yang, and I think you are lucky guys that being accepted into these programs, dan I hope jangan sesekali kita kata membuang opportunity ini, dan teruskan. Saya harapkan terus your life, your future into the rail industry. Thank you so much, and I hope that jobs will be no problem for you. Thank you. Assalamualaikum warahmatullahi wabarakatuh, dan selamat insyaAllah tuan-tuan yang 20 orang ini untuk terus meneruskan your interns ataupun your apprenticeship di UTHM dan juga di Prasarana for the next 4 weeks, dan please enjoy your internship or your apprenticeship. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much. Next, we would like to invite Yang Berbahagia Profesor Datuk Technologies Dr. Wahid bin Razali, Yang Berbahagia Profesor Dr. Ismail bin Abdul Rahman, Yang Berbahagia Profesor Dr. Khalid bin Hasnan, and the students of the program for photography session on the stage. Thank you, Yang Berbahagia Profesor Datuk Technologies Dr. Wahid bin Razali, Profesor Dr. Ismail bin Abdul Rahman, Profesor Dr. Khalid bin Hasnan, and to the students, we wish you all the best for your future in Prasarana Berhad. Ladies and gentlemen, this is the end of the lecture series program. We would like to thank all the invited guests for taking the time to attend this ceremony. On behalf of the organizers, we apologize for any shortcomings throughout the ceremony. Till we meet again in the next lecture series. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.